Not to be punny, but this section really matters. So matter is anything that has mass and takes up space. So here we see an astronaut, and he is walking on the moon, doing his moonwalk thing, probably just finished putting a flag down. But he should have the exact same mass up on the moon as he does on planet Earth. But his weight, on the other hand, is completely different. So if he weighed 180 pounds on Earth and his pack weighed 180 pounds on Earth, then he would weigh 30 pounds on the moon and 30 pounds for his pack. And that's because the gravitational force of the moon is 1/6 that of Earth. And so his weight is just 1/6 of what it would be. And that's because the moon is so much smaller than the Earth is. And so if you were to go to a place that is a whole lot bigger than the Earth, then his weight would also be so much larger. And that's just because that planet would be exerting such a larger force on this astronaut. So after thinking about the definitions for mass and matter and weight, we wanted to look at physical properties and chemical properties. So remember, a physical property is just anything that you can determine, any property that you can determine without doing a chemical reaction. Whereas a chemical property, you have to do a chemical reaction to determine. So physical changes are typically just anything that can change the form of the structure of the substance, but not its chemical composition. So just like you see water is H2O, that means it has two hydrogens for every oxygen. So oxygen's in the middle and hydrogen's kind of like wings out to the side. Water always has that formula, always. And so if we do a physical change to water, that means we've changed maybe how slippery it is because now it's ice, or we've made it fly around like crazy by turning it into a vapor, but we have not changed the property of water, that being H2O. And so physical change is anything that does that, where you're not creating a new chemical, you're just changing it in some way. So distillation, filtration, boiling, freezing, those are all physical changes. But how can we identify then a chemical change? And so I think this list right here is kind of some of the things that have helped me identify chemical changes. They're not perfect because, like, producing bubbles. Okay, boiling produces bubbles, but it's a little different. So with color change, what you're looking at is, like with these leaves, you're seeing a change happen that changes color. So maybe the salt went from a white color to a purple. You see a real change, and typically that's because different molecules are different colored. So therefore, by changing the molecule from one molecule, you change it to another, you get a color change. Now look at the bottom. See how it says chemical changes can be described by a chemical reaction? So we'll get into this more in other chapters, but basically you have the reactants on one side of the arrow and the products on the other. So notice how in this case you've got H2 and O2. That's hydrogen gas and oxygen gas. If you combine those together, you create water. So those have very different properties because you don't want to drink oxygen, you want to breathe oxygen, and you would like light hydrogen gas on fire, but water you can drink and you consume, and it's very, obviously good for you. And so chemical changes change all kinds of properties about substances, and so just trying to figure out how can we identify them is helpful. So that's color change. Production of an odor, so when a skunk releases its wonderful smelling pungent odor, you're getting a chemical change that's actually happening inside of him. Changing temperature, now this is not just I heated it up or I cooled it down. It's when the chemicals react together and thus release energy or absorb energy for the reaction to take place. And so this right here is called a thermite reaction. It's a really neat reaction. If you were bored, go ahead and Google it. There's some really cool stuff out there. Production of bubbles, so not simply boiling, but you leave something alone and it starts getting hot over time. So if you combine, I know you wouldn't actually do this probably, but if you take sulfuric acid and hydrogen peroxide and then you combine them together, that heat that's produced, it can burn your hand. And so that is, it produces bubbles and it's doing a chemical change. And then formation of a solid, that would be like this. You're producing it, what's called a precipitant, but you see a liquid and a liquid combined together, and then now there's a solid that is very visible. It's the same thing with the bubbles, and before those bubbles are a new gas that is being produced. And then production of light, like I mentioned earlier, bioluminescent, but in this case, instead of being the nice plankton, these are some horrible creatures of jellyfish. So if you see a production of light, that's typically a really good indicator that it is a chemical change. So let's practice. So fireworks exploding. All of these things, if you want to pause and try and write down a P or a C next to it, just to determine it's a chemical or physical change, I recommend doing that, and then I'm going to tell you all the answers right now anyway. But go ahead and give it a try. So think about it. It's like with the first one, fireworks exploding, that produces light, so therefore it's going to be a chemical change. Squeezing oranges to make orange juice, that's physical because you're just simply moving the juice from inside the orange to your drink. Frying an egg, it's a chemical change because you're doing what's called denaturing the proteins. So you can't take the egg once you've fried it up and pour it back into its regular, shell. You just can't do that. And so you've completely changed the structure of those atoms inside of the egg. Pouring milk on your oatmeal, it's physical. You're not reacting it in any way. It's just soaking your oatmeal up. Burning leaves. Anytime you see the word burn, that's a really good indicator you're doing a chemical change. So you've released an odor and you've changed the color of it. Making salt water to gargle with. So with salt and water, all you're doing is combining them and they're just interacting. They're not doing a reaction. Cream being whipped. Once again, you're just changing what it looks like. You don't get any of the odor, etc. Burning toast, burn, chemical. Freezing is always a physical process. Same thing with melting. Those are very physical processes. Let's try some more. So once again, pause your video if you want. Write these down. See how you did. Hopefully you're a little better this time around. Glass breaking, definitely physical. Hammering wood together to build a house, physical. Rusting is an oxidative process, so you're actually combining oxygen with whatever the metal is to create a completely different compound. Melting butter, once again, melting is physical. Separating, if you're just separating, you're moving it from one place to another, that's physical. Spoiling food, anytime you see spoiling, you're going to it's going to smell bad. That's what happens to food over time. It starts to smell bad. That's the odor it was referring to, so that's chemical. Mixing lemonade powder into water, you're just mixing, you're combining it, you're not creating a reaction. Mowing the lawn, now here I have physical next to it, but I really could see an argument for chemical. So when you mow the lawn, all you're doing is cutting the grass, and so you have two blades of grass. But if you notice when you mow the lawn, you always smell it. You could tell when somebody's mowed the lawn, and so that smell is the odor, and so the reason that it is a chemical and a physical, the act of just cutting is just rearranging in form, that's physical, but the release of those organic smells that you hear, that's actually a chemical process that the blades of grass are releasing as kind of like a defense mechanism. So that actually is chemical. So I could see an argument for either. Corroding metal, chemical. Bleaching your hair, you definitely smell that, that's chemical. Alright, so now let's move on to classifying matter. So solid, liquids, and gases, they all do matter, and they all are matter. So I like this little meme, solid, liquid, gas, help me, I'm melting. But things do change. So the process of moving from like a solid, liquid, gas, it's typically considered like in this picture, those are all physical changes. Okay, but you could do what you see here, and that transfer into a liquid probably is a little bit more of a chemical change. But I love this meme. Are cats a solid or a liquid? Well, a liquid has a defined volume and takes the shape of its container. Therefore, we have scientific proof that cats are liquid. So remember, solids have a definite shape and volume, liquids have a different definite volume but take the shape of its container, and gases take both the shape and the volume of the container. Now, something else to be noted, gases move the most. That's because they're always bouncing around. If you fill up a balloon, it's got gas all inside, and those little molecules are moving around like crazy. Alright, so when we're classifying the matter, then there's the solid, liquid, gas. You can classify it like that, but you can also use this flow chart. So we've got, this is kind of one that I just use. I think it helps me a whole lot. So the idea would be everything is matter. Everything in the whole universe is matter. But then you ask the question, is it variable in composition? Meaning, is it made out of one substance or multiple? If it's got multiple things, then it is a mixture. If it only has one thing, then it's a substance, or a pure substance is another way of talking about it. Then within mixtures, if you have visibly distinguishable parts, you've got it's heterogeneous. If it's not visibly distinguishable, which means you look at it and it all looks uniform, it's homogeneous. Then your substances, if it's got one type of atom, it's an element or elemental, and then if it's got lots of different types of atoms, then it's a compound. And something to note, just kind of a definition thing here, I don't think the book really mentioned it, but molecule is a group of atoms bonded together as a unit, whereas a compound must include at least two different types of atoms. So C60, which is called a buckyball. It looks a whole lot like a soccer ball, but it's composed entirely of carbon, like in carbon, like graphite in pencils. But it is a molecule, which means there's a whole 60 carbons bound together in a soccer ball shape. It is not a compound because there's only carbon atoms bound together. So you could call it a molecule, but you're not technically correct in calling it a compound. Whereas water could be considered either a molecule or a compound because it has groups of atoms bonded together, and it also has at least 2 different types of atoms. So hydrogen and oxygen are the 2 types. So let's work on classifying matter. So here are 4 different types of matter. In the first one, in A, we have dirt, then gold bars, then we have table sugar, then milk. So what I want you to do, I want you to pause the video, maybe go back to the last flow chart, and ask yourself, what is dirt? How would I classify it? What is gold? What is sugar? And what is milk? So the first one with dirt, you can see there's plants growing in it. It's got some particles in it. It probably has a little bit of, things that are really granule, but then other big chunks of maybe some decomposing material. So with dirt, we got to ask ourselves, it is matter. It is a mixture. So if we move over here, it's a mixture. And does it have visibly distinguishable parts? Yes, we can see stuff growing in it. So it's heterogeneous. Then with gold, we're going to ask the question, what is it? So, does it have variable composition? No. So it's a substance. Does it contain various types of atoms? Is there anything else in the gold bar? Now, technically, yes, but that thing does say 99.99% pure or something like that. So we're going to assume for the sake of this lecture that no, it's gold, and it's an element. Specifically, it's got gold atoms. So gold is an element. It is gold. Okay. Then what about sugar? What is sugar? So if we go back to here, sugar is a mixture or a substance. It's a substance. It's pure substance. It doesn't have anything else but sugar in it. Does it contain various types of atoms? It actually does. So it is a compound. So if we look at sugar, sugar has the formula C12H22O11. And so with that, it's got 12 carbons, 22 hydrogen atoms, and 11 oxygen atoms within any one individual atom, or molecule of sugar. And so within that big pile, there are tons of sugar molecules in there. And so with looking at that, that is definitely classified as a compound. And then what about milk? So milk is a mixture, but it's uniform throughout. So I hope you said homogeneous mixture. So with that, that's the end of this unit. Now go read section 1.7.